This conference will now be recorded.
Okay, good morning, everybody. Welcome to the OCP HPC Sub-Project meeting on December the 13th, 2022. Today, we've got a meeting, we've got an agenda. I'd like to thank the guys from XCon Technologies. They're going to give us a brief presentation on what they're up to on the CXL switch side of things, which we've been obviously talking about in terms of would it be possible for us to build an HPCM module with a CXL switch to begin with. So I've asked them to just give us a rundown of what their devices are and where they're at. Then, as some of you have probably heard already, we had a meeting with the DOE, or DOE held a workshop for all of the people that responded to their requests for information on the advanced computing ecosystem. And so they gave an overview. They are going to release the slides, and I believe the video recording as well, which we can share, but we don't have them right now. But myself, Paul Hartkey, and Michael Choi were on, unfortunately, Philippe couldn't join us because he's a Canadian citizen, and I don't think his colleague joined us. And
Brian Allison was on.
And Brian Allison was on. Thank you. I was going to say, actually, let me just ping Brian to see if he's going to join us today. I knew there was somebody else. Let me just send him a text. Okay. Yeah. So we were all on yesterday. We have an additional meeting on this coming Friday, where we have a one-on-one with them, and so we'll hopefully we'll get some direct feedback on our proposal and whether there's any likelihood of us partaking in some projects or getting some funding one way or another from them. So we'll get into the detail, but at least the feedback we got seems somewhat hopeful that there might be an opportunity for us. Okay, so first of all, we've got the introductions to new attendees. What I'll do is, Jim, you're new, but we'll wait for your colleague to join JP, and then we'll get you both to do a quick introduction. I don't believe there's anyone else new on this call. Hey, John, I see John Stewart's just joined us. Glad you can join us. John's not new from Dell. Okay, so let's just maybe, because we're waiting for JP from XCon Tech to jump on the line, he's about 10 minutes away. Let's just go into the discussion. Hopefully Brian can join us. Let me just see if he's responded one way or another. He said he'll be there in a minute. His laptop is rebooting. Okay. So if I give a quick intro to roughly what we heard, and then maybe Paul and Michael, you can give your flavors of what you heard yesterday and how you think it's applicable to what we're trying to do here, and maybe we can extend it to a wider discussion of how we want to try and move it forward, or how we want to shape the meeting on Friday. So yes, so basically what they did is they said there were a total of 49 responses to their requests for information. So that's quite a large response that they've been sifting through. It covered that they covered a lot of areas, really, in terms of, from the big machines they want to build, but the significantly changing architectures that they're dealing with, and also the use cases are also actually growing. Each of the labs basically funds a big machine of their own, and that's to solve a specific problem that they're trying to solve. So these machines are typically targeted to one or two very specific problems. And traditionally, they've gone to a very big vendor in a round robin sort of fashion. And historically, it was Silicon Graphics, SGI, Cray, HP, IBM, to some extent Dell, and obviously the big silicon vendors. I think Intel have been a lead on several occasions, but a lot of the times the silicon vendors are key players, but they're not necessarily the prime systems integrator. So they work very closely with those. And as an example, the latest HPC machine, Frontier, was led by HPE, which was originally Cray, but they acquired Cray. And so it's led by HPE. It had the Cray slingshot switch in it, and it also had the AMD EPYC processors and AMD's latest generation of GPUs. Well, they're bifurcating their GPUs into two different areas, but I think that it was one of their GPU technology-based devices that was in an OEM format. So that was the shape of that one. The big machine before that from the US was the Summit machine, which was IBM and NVIDIA, and Mellanox were the ones that drove that particular machine. These are two Oak Ridge machines actually, which is ones that I've been more aware of. So the main driver of this is for them to get to the next big machine, which is going to give them up to 10x of a lift over the previous machines, and it's how are we going to get there. So they were sort of clear on the challenges that they wanted to, this is going to be more of a heterogeneous platform, and they do need this to be, or they want this to be more modular and more upgradable, which are key areas that we obviously focus on. They also touched on the granularity of modularity as well, which is something we're a finer grain compared to these big nodes that we had in the past. So across everything, they have across all of it, they covered the software aspects, the challenges there. They did touch on CXL is being quite interesting from an industry standards perspective, but they also said, historically, they go for solutions that solve their problems, and if it has proprietary technology, sometimes that's a necessity, and that's the quickest way to the fastest machine. And so, they don't necessarily lead with the standards or drive the standards. They follow the industry's best practice. Excuse me, let me just get rid of that. So it looks like CXL would be an interesting direction, but they're going to need to see the traction on that. They did say, when I asked the question around funding, they are geared up for funding these big machines to solve these big problems, and that's what this is all about. But there's lots of other funding projects that go on that they did list. In fact, I did have some notes on this. Those look at certain areas, like specifically AI, let's say, for example, or particular technologies that are going to help, and they get funded individually under different programs, and they are all aligned with the bigger scope of the big machines. So the research results or the investigations do feed into the bigger machines. So there are funding opportunities, not necessarily directly from the program of the big machine, but from these smaller activities, which could be where we can actually get involved as well. So, hey, morning, Brian. As you say, you're on. Oh, there you go. Good morning, Brian. So, Brian, just for your benefit, I'm just giving a rough rundown of yesterday's DOE workshop right now.
Sure.
And you were on, Paul Hartke was on, and Michael Choi was on. I don't think anyone else was on. So I was just going to say, I was just giving some background. If maybe you could each give your perspective when I'm done, in terms of from what you heard and whether how you think what we're trying to do maybe aligns with that, or if there's anything we can do specifically to see if we can maybe for this Friday, this upcoming Friday's meeting would be what I'm trying to prepare for, really. Okay. In summary, they did cover a lot of topics. They did address the systems area. They did say they want more participation of smaller companies with the best technologies. They want to embrace startups with all these different heterogeneous silicon, but you know, they're used to having one throat to choke, one big prime, and so that's a challenge. Cliff, actually, one of the VPs of OCP was on the call, and he and I asked some questions. So the management of OCP want to find out how OCP can participate in helping to drive these directions with the DOE and the labs, and how can we make this happen so that small companies can participate in an open fashion and drive our industry in the right direction as a whole, rather than the big incumbents sort of dictating the way and everyone else having to follow under that wing. But they haven't solved all the problems for sure, and they're trying to work out how to do that. And Cliff made the point that, you know, OCP wants to find out how to do that. I've had previous discussions with the various people in the OCP management about would they like to somehow be a prime, but they're not. They're just OCP is a standards body vehicle. They don't want to get actively involved in the projects. So we've got to work a way that can herd us. We're a bunch of cats and we need herding. And so we're trying to work out a way that how can OCP participate in this, keep everything nice and open. You certainly open at the interfaces so we can bring our own innovation and our own technologies, you know, which are protected, but we can work together to build an entire ecosystem and a platform that is that we can all benefit from. So bottom line, I was encouraged, and by the way, with regards to Cliff is going to join us on the Friday meeting, the one-on-one we've got, and OCP will have their own meeting as a whole in January with the DOE. So good news really is that this is an active area. There is a lot of interest from OCP beyond just ourselves, and the feedback I got, I'm encouraged that there is a potential way forward, that we can get some funding for all the small companies to try and experiment. The more radical experimentation that we're doing here, we may be able to find a path. Now I am ever the optimist, so take that with a pinch of salt. That's me. So Paul, Michael, Brian, who would like to dive in first and just give your perspective?
Okay, this is Michael from Samsung. Yeah, you already, covered well overall, and then to me, I was very interested on, those advancement in process and memory technology stuff, because of in the data center, in the HPC environment, pretty much, this resource disaggregation is covered except memory. So this memory, the disaggregation, these are, which is memory pooling or sharing solution is actually critical to solve, the issue from the acceleration environment. So these are, our homework, how to overcome this limitation. So they were talking about like a packaging advancement, and then like a novel architecture about this pooling, memory pooling, and then accelerator pooling for AI, machine learning, those accelerators. So those was very interesting to me. And then along the line, they mentioned about the advancement in high performance extreme heterogeneity, and then the disaggregated computing stuff. So especially, they were doing like a monolithic, oriented, humongous system development before for the HPC subject. But now, they're changing the paradigm to like modularity and, more the upgradable way or serviceability. So for that subject, they mentioned about the new technology like CXL and then the UCIe. So I guess for this DOE mission, what we were doing like in OCP HPC, the sub-project, this is the main subject, I believe. And then in terms of this new mission, the modularity driven, the building the scalable, the powerful supercomputer system. So I think what we were doing, which is HPCM, is a really good fit. And personally, like CXL, UCIe, along with this silicon photonic technology, while we are reducing the energy consumption in the HPC and then futuristic data center environment, also we can reduce the those energy consumption together. So I guess we can do a lot of stuff, on their requirement using this our approach, HPCM approach for HPCM driven, like the CPU pooling, GPU pooling, FPGA pooling, and then memory pooling, and then storage pooling too, storage together. So I guess we can do big contribution for the DOE mission, I guess. Yeah, that was my impression on the yesterday, the DOE presentation.
Thank you, Michael. Much appreciated. Paul or Brian, who wants to go next?
Yeah, I can kind of go next, I suppose. I took a number of notes, so here are the kind of notes that I had said. On the hardware side of things, there's basically 4 areas that they want to focus on: processor and memory enhancements, disaggregation and heterogeneous computing, next-gen storage, and HPC networking. One thing they did say today is everything is a fat node, right? I think I heard that. And that there's no multi-tenancy today on any node. I think I did hear that. What was kind of interesting to me, Alan, is they started off talking about, well, they'd like to have innovation around chiplets. They want to mix and match chiplets. They want to have systems that are modular and upgradable. But then on the back end of it, they said a lot of the labs still want to remain monolithic, right? And it's really challenging for them if they have to keep on doing, let's call it upgrades, and then I think doing a regression. I think that's problematic for them. So it's kind of, for me, it was like they were almost talking out of both sides of their mouth a little bit.
Yeah,
so
yeah.
That was kind of interesting from my perspective.
Right.
I think a couple of big things that I kind of latched on. They mentioned CXL a few times, so I still think they're trying to understand what that means. And they want to compose their resources both at a fine and coarse level, but I wasn't quite sure what they meant by that. On the storage side of things, they basically said checkpoint restart is very important for them. They want to do complex offline analysis. You know, telemetry is very big for them. So if there's anything that we can do on telemetry, that was, you know,
Oh, yeah,
I think efficiency is very big for them, because I think what they're finding is they build these monolithic things. Think Frontier, right? For instance, there's a lot of that stuff that just isn't used, right? They do all these workloads, but you know, I think there's inefficiencies all around the block. So they want to try and improve upon that. They did mention improvements in network telemetry, load balancing, process placements, scheduling, things like that. On the software side of the house, they mentioned open source technologies to improve upon their software sustainability. And I think one thing that I think it's a big change for them is to go more towards a workflow-based approach, which I don't think they've been doing historically. I think another big area that I heard, and I'm not sure if there's something that we can do, silent data corruption is an increasing problem for them.
Yeah.
And trying to solve those types of problems and needing tools to identify marginal hardware and to detect intermittent failures. Checkpoint restart is the dominant in mitigation for that. But they also want to investigate additional mitigation techniques in hardware and in software. One thing I did see that was kind of interesting, they didn't latch on to quantum really hardly at all, right? They're just like, well, if you can get it to work with our conventional, you know, compute that we do today, that'd be great. But they didn't latch on to quantum, from what I could tell. And then
yeah, I guess that was treating that as a co-processor sort of thing, wasn't it? It was.
Yeah, right.
It's just we want to be able to fold it in somehow, but yeah, I get you.
And then I think I also heard thermal management's going to be big. And then they talked about improved thermal management through planar integration using silicon photonics. I think that's an area that they're going to focus on a lot as well.
Oh, really? I missed that.
Yeah.
So say that again.
It was improved thermal management through planar integration using silicon photonics. I don't know if they talked about it, but it was on one of their slides.
Wonder what they mean by that. Is that just a fancy way of saying co-packaged optics?
I think so.
Okay.
That's how I interpreted it, Alan.
Okay. Well, that makes sense.
Why they didn't just say that, I don't know. It was weird phraseology, but I assumed what you just said.
Right. Okay.
They didn't mention it further, though, which was surprising.
Well, yeah. So the co-packaged optics one is an interesting one. There's a long way to go on that. Apart from there's some obvious easy wins, but
right.
I think probably NVIDIA are blazing the trail with that in AR Labs if all their press releases are to be believed.
You know, well, they brought up the age-old argument right at the very beginning about, do you move the data to the compute or do you move the compute to the data? They did bring that up again.
Yeah.
Right. So I think they want to. That's why I think they're talking about like chiplets and UCIe. But this is getting back to the point of, well, do you want a monolithic architecture or do you want to be able to upgrade things?
They did say that the chiplet approach is actually in the wrong direction for power, because a reticle size,
yes, they did say that.
Full reticle size piece of silicon is the most power efficient.
Yep, they did say that.
They did. That was interesting.
Right. So they talked out of both sides of their mouth for sure.
But they did emphasize modularity and granularity, and I think this is where we play. I think the chiplet world is a tough old world in terms of an ecosystem rallying around it. When you look at all the challenges and all the known good dies and the yields, and oh my God,
Well, I think, in my opinion, you know, like you said, I think if you can get these companies to basically adopt the form factors that Open Compute has been doing in other environments, because I don't think they're there, right? That's where you could get a lot of potential play, right? But I don't think they follow the mantras of what, like, let's say Meta and some other people are doing as far as form factors, right? But maybe they're willing to change their ideology on form factor and connections to get the compute quote unquote, closer to the data.
Yeah. In fact, I've got some more ideas on what we maybe have to do to get people to understand what we're doing at the next level up.
I mean,
Okay.
I've been at it for 30 years. It takes a lot of effort.
Yeah. Paul, anything else to add from yourself?
Am I trying to get off mute?
Yes, you're off mute.
You're on.
Something keeps saying recording every like 10 seconds. Which just that they were interested in the whole business model stuff, right? I mean, that's useful as well, right? I mean, as there's fewer and fewer primes, et cetera, how do they do that? It's just interesting, right? And so part of it, I think, is breaking up the big monolithic systems. The whole one neck to choke, et cetera. They did say, should they get more into the system design aspect or whatever? I think for their mission, they will have to. So how can that be leveraged? Anytime you find both business and technical alignment, that's a good thing. So that in particular is a thread to pull on. But I see we're at the bottom of the hour, Alan. I don't know if our guests are ready or not.
Yeah.
But yeah, that was really interesting.
Okay. All right. Well, no, that was good. Thank you, guys. Good input from everybody there. So, I mean, bottom line for me is, sorry, could you paste a link to a meeting note here? This meeting note, the minutes. Yeah, sure. Here we go. Yeah, so in general, I'm highly encouraged by the tone of the meeting and the potential and the potential for the OCP as a whole as we move forward. And I've said to the management before, this is a big area that we really want to put our focus on. And by the way, we can touch back on this if we have time at the end, but the energy-centric computing theme, the more I talk to people about it, the more it rings true with everybody. It's all about the power and efficiency is the critical thing. This focus on chiplets in a package is very local minima, to quote Elon Musk, in terms of the focus. It makes sense of just keep sucking everything into the processor, but it's still processor-centric. You need to
chiplet's not really processor-centric.
Well, it's still sucking everything in next to where the processor is. But
anyway. Well, you get performance when you jam things together because the distances are shorter. So time is distance.
Right, exactly. So there are huge energy efficiency wins, but it's a bit myopically focused, where you can do it more of a systems.
Well, I think the chiplet stuff's more about getting something knocked together fairly quickly rather than doing ASICs.
Right.
So you can create a machine for a particular compute problem quite quickly.
I think the best example of the chiplets is the HBM. It's getting that bandwidth without burning the massive power.
Well, I mean, I always take that as a bad example. I mean, what the chiplet things will let you do is mix a bunch of different stuff together. Putting a whole lot of memory in a box is always a bad idea. It's a volume versus surface thing.
I don't want to derail this with a dive into that topic, but okay, look, the bottom line is it looks like the DOE, I think Paul also mentioned at the beginning, that maybe it wasn't as conclusive as people would have wanted it to be, but it's clearly opened up a good discussion with the government and DOE about our challenges and about their challenges of these big machines. And so I think there is a tremendous opportunity for OCP as an open ecosystem really play here, and it's just finding out how to do this with herding a bunch of OCP members, being the cats, and their traditional one throat to choke approach, as I've discussed with them many times in the past. So long story short, very interesting. On that note, in terms of we've said maybe rallying around CXL is a thing that we can do as a work group to really try and get into our stride here, because we're trying to establish an ecosystem as an industry around CXL, and there's clearly tremendous momentum there. But there's a long way to go before, you know, in companies like AMD have got their EPIC systems, so you've got these processors beginning to come out, but you're fairly limited in fairly expensive equipment to actually start doing interoperability and getting things up and running.
Well, I think the problem with something like CXL is it doesn't have much abstraction. A lot of the stuff that we've done at OCP lacks abstraction.
Right.
Which means that, you know, everybody says we'll do a CXL, but it's like one specific solution, and it's not a particularly good one in my mind.
So the beauty here is if we can do it, if we look at what we're doing here is a Raspberry Pi for high performance computing. You know, you've got that maker community at the IoT end of the world, where you can make some really sophisticated products very quickly out of plugging things together, and then you can turn them into a real product with real money later. And if we can really enable all of these brand new silicon players with modules that can be easily plugged together in media and cabled together between processors, all the heterogeneous accelerators, etc. But really, on the basis there's a lot going on around CXL and UCIe, it makes it from our
the UCIe thing is like competes with BOW, but I kind of look at those two things and say, well, they're more or less the same thing if we've got a level of abstraction above.
Well, to be honest, at our level right now, CXL is the main one, because this is all getting out of the pack.
But all the CXL is like a way of moving blocks of information around.
So go on.
No, go ahead, Alan. I'm cognizant of the time, so I think you had some guest speakers.
So I've invited XCon Technologies in to give us an overview of what they're up to in the CXL space, CXL switch space. So we've got Jim Cow on and JP, I believe. Would you both like to quickly introduce yourselves to the group, and then we can bring your presentation up?
Hey, JP, would you go first? JP, can you hear us? Hi, let me introduce myself first. You know, hi, this is Jim Gao, you know, and I'm in charge of software development in the SCOM. And JP is our VP of product marketing. Today is going to present our chipset solution to the team. Let me see how JP may run into some technical issue. Let me offline to discuss this with him.
Yeah, it looks like his microphone's on, but we can't hear it. We can't hear you, JP. Maybe your microphone's not working. Headset.
JP, can you try to present your slide?
Hey, JP, you're on again. Can you hear us now? Let me stop presenting, actually. There we go. So with JP, you're on twice, and we're not seeing your screen if you're trying to share.
Ah, yes, technology.
Ah, who said that?
Nobody.
I didn't. Ah, yes, technology. Whoever said that, I didn't. Who was that? I can only see JP's mic on.
It was me.
No, it's Brent. Jim, are you in the same office, or I guess you're working remotely?
Oh no, I'm still at the office. At home now, and for some reason I'm not able to contact the JP. It seems that his system is down at this point. Give me another.
Looks like his chat is working. Looks like it's responding from the chat window.
Yep.
Oh, my MacBook needs to get set up GoTo. He's setting up GoToMeeting on his MacBook.
Alan?
Yeah.
This is Michael, and yeah, I clicked the link, but it asked me to get some access, right? So
Yeah,
request.
what I'll do is I'll just change it. I've just changed it to anybody can access.
Okay.
Try that.
Great, it's working. Thank you.
No problem.
Well, it's working right now. Thank you.
Okay, JP, you're in 3 times now. Can we hear you? Can you hear us?
Hello, can you hear me?
Yay! Yeah, yes, we can. You've got a bit of an echo. It looks like your other connections are still.
Yeah, some echo.
I'm gonna mute, or I'm gonna try to mute your other ones. You set
better?
That's better. Okay, looks like we've stopped the echoing.
Yeah, so let me try to share, because I know some new app sometimes need us to set up sharing function. Right. Oh, sorry, I have to restart the app because after the setting. Hello, can you hear me?
We can, yes. Yeah, can you hear us?
Yeah, so I think I still need to set up the sharing function.
Maybe running out of time for this.
All right, so should be able to share right now. Do you see my screen?
Yes. Excellent.
Oh,
Okay, we're good. We've got 15 minutes, so hopefully we can. Thank you for your persistence, JP. Much appreciated.
Oh yeah, I see it too. All right, great.
I think it looks good, like what it is.
okay. So let me get started. I mean, somehow the display mode. So yeah, we're a startup company. We're called the XCON Technology. So we're go to the next page. So we are founded about 2 years ago. We started about 2.5 years ago, and we're a Silicon Valley based company. So majority of the employees are based in the San Jose, Silicon Valley area. So right now we're growing pretty fast. We're more than 32, 33 people, and still hiring. And got our funding as well. So we should be able to survive the next 3 years. And this is building, where we have our office. It kind of located in San Jose, a little bit north of Campbell, if you are familiar with this area, and south of Santana Row. So the problem we try to solve, one problem is this memory bottleneck problem with all this modern computing, data centers, AI computing, because the memory DRAM bandwidth, DRAM capacity has always been a bottleneck for the computing industry for many, many years. And this picture kind of from Meta and Google, it shows, the processor core count versus the DRAM bandwidth, available bandwidth for each of the core. So that kind of decreasing or keep flattish. But actually, all the new application computing require much more memory. And the industry kind of come together with this approach to use CXL to unlock the potential, available of this DRAM. And our switch kind of is an enabler. So switch would be enabling this memory expansion or memory pooling to a very large scale and be able to solve this problem very nicely. So yeah, I think I won't spend more time because I believe you guys are all expert on this. Then the second issue is the problem or the market we think is the future computing all kind of going to be a composable disaggregated architecture. And this kind of architecture for a rack, for a computing rack, the kind of networking infrastructure going to be switched to a CXL-based kind of infrastructure. And people are talking about some kind of similar to a top of rack for CXL kind of routing. So we again, we provide a switch that's kind of in the center to connect every functional unit of a rack. Of course, there's a lot of benefit for doing that. So let me move on. So we're a startup. We're basically a chip startup. We're making the ICs. So our product mainly is just IC. So the company's been in business for 2.5 years. And we already taped out our first ASIC version of an engineering sample chip. So that is the world's first CXL 2.0 and also a PCIe Gen 5 switch, because CXL is built on top of PCIe Gen 5. The chip got the largest biggest switching capacity so far in the industry. It got a 2 terabyte per second bandwidth. We have a total 256 lanes, the Gen 5 speed lane. And our chip design, started from scratch. We basically have our own switching architecture. For doing that, we very much focus on CXL and the data center computing. And we're able to reduce the port-to-port latency to, basically switching latency a lot. Basically, we think we have the lowest latency in the industry for now, and also the lowest power consumption per port. So the chip was taped out early this year, and we got the chip back around the end of July, and we having this chip almost 3-4 months now. We've been doing a lot of bring up, validation, and development. And next page is a kind of a brief of what our switch supported spec and the features. So our switch is a CXL 2.0 switch, but we can backward work with the CXL 1.1 server CPUs, like Intel's and AMD's. The new product they have are all CXL 1.1. So our chip can work with these CPUs and do the memory pooling or memory sharing through some proprietary method. But once everybody, the processor also go to the CXL 2.0, we will, work with the ecosystem, just based on the CXL 2.0 spec. So for 2.0, we also support a 2.0 Fabric Manager interface and the building logics for supporting all these Fabric Manager functions. The chip, our chip, going to have a total of 32 ports, and each port is can be by 8. So that is a kind of the brief picture of what our chip looks like. So let me move on. So this give you some kind of a real feeling of what that looks like. This picture on the left is our reference design, the switch, the big board for our switch. So we put it into a chassis. And on this big board, you see there's 2 CAM slots, and the rest are using the MCIO connector. And in the middle is our switch. And the switch is a big chip. This heatsink on top is a kind of we over designed it, so it's a little bit huge. But in reality, our chip, the TDP is around 120 to 130 watt, so it's not that much power hungry. Then the setup here on the right is our kind of a picture of our lab. We have this switch, our switch board, and then we plug in a memory module into the CAM slot, and we also connect with Intel's RHCD reference platform, Sapphire Rapid. So our chip would enable memory expansion. So to a certain extreme extent, each switch can, allocate the 31 ports, right? We total have 32 ports. In the extreme case, we can have 1 port connect to the host, to the server, and the rest just occupied with the memory devices or other kind of computing medias. And some of these CXL devices, they can get up to 1 terabyte. So right now, maximum we can see, of course that's going to be expensive, but if you really want to do it, you could one switch just enable 31 terabyte of DRAM expansion. This is the extreme case, but of course I think a mainstream lot of hyperscalers and HPCs, they are looking for memory pooling solution. So memory pooling solution is basically multiple hosts. They through a switch and connect it to a very big memory pool. Although this picture is kind of borrowed from the CXL consortium, the picture, the kind of block on the left shows the memory device are a single logical device, but soon the device will going to support a multiple logical device. So of course, the multiple logical device would allow the even better utilization of this memory pooling, right? Memory pool. So be able to finally segment, allocate the exactly needed memory to a very fine level. That'll push the utilization of a memory pool to a much higher level. So our switch would be able to support all these functions. As mentioned, those multiple hosts that this year and the next year they are going to be CXL 1.1 compatible. So our switch can work with them. And then future in the next or 2024, those processors are going to support 2.0. So and our switch would be able to work with them as well. So that's kind of my whole presentation today. I think we kind of a little bit short of time. Sorry, kind of a little spend some time trying to configure my meeting. Yeah, so we are a startup company. We're very focused on just doing the CXL and PCIe Gen 5 switch. That we're working with what we call the ecosystem partner. So we're working with the processor and the DRAM companies all together to enable this kind of memory pooling and in the future the composable computing architecture. So that then I have a very short kind of our product roadmap. You can see we have our first generation switch, and then we continue work on our second generation, which is going to be CXL 3.x based. So that's about it. Any questions before we running out of time?
Thank you very much. Yeah, I guess it's very interesting. No real time for any questions, but so for everyone's benefit it's on, obviously we've been discussing, it would be great if we can enable the CXL and enable our efforts maybe with a CXL module from an enablement perspective, a CXL switch module. And so this is the first device I found, these guys, that has 256 lanes, and so could actually make use of a good number of the 320 lanes that we can support on the proposed HPCM module. So I would like to try and see if we can make progress in actually starting an HPCM module with this switch on it. These guys, I think, would be interested to partake, but they would need one of the bigger players to actually show an interest, at least. So I'm not putting words in your mouth, JP or Jim, but I guess Michael at Samsung, Paul at AMD, Brian's not on anymore. It's from IBM. This, certainly, certainly there's some interesting possibilities here, and I don't know if any of you guys from your internal teams could maybe muster up some interest to try and make this module in some way resources or finances. But in the meantime, we'll continue to plod on with trying to get DOE funding. Obviously, that's a long road for us to take. So I'm not sure we're going to get funding quickly out of that. So if we could bootstrap, I think if we could bootstrap an HPCM module with this switch on it, and Samsung's SSDs connected to the switch in the module, I think we might then succeed in getting other FPGA processor, heterogeneous AI connections into this. Even if they're only PCI devices as well, that's the nice thing about CXL is we can connect PCI devices today. So we might get a Raspberry Pi type ecosystem rolling if this is our first module. That's my desire. No time to discuss it really. I realize we're 2 minutes over, but thank you very much, guys, for presenting this. Looks like a great product, and I'm sure you're going to be very successful with it. So best of luck. And
thank you.
We've cancelled. We're going to cancel the next meeting because it's between Christmas and New Year. So everyone have a good holiday, and look forward to seeing you in the new year.
Thank you. You too.
Thank you.
Thank you.